did not have tons of formulas. This would be formula number 2. Literally, they are the same thing. It's just this one is solved for a squared, so it's solved for a side. This one is solved for the cosine to find the angle. So it's all about being able to solve the triangles. But these are the pieces we have here. So our law of cosines we can use to find our angles if we have side, angle, side, or if we have side, side, side. So we can find our angle from those. The quiz will be over law of sines only. What's up? This would be formula number 2 for the chapter. I told you this one had less formulas. That does not mean none formulas. The next chapter has just. It's really, yeah, and that's really one. Like that's really one. Even though it looks like 2, it's really just 1. And the next chapter has very minimal formula. So it's just going to be a matter of which way we set this up. If we're looking to figure out a side, we need to know the other 2 sides, and then the side we're looking for is angle. So we need to have, if we're looking to figure out side A, we need to know side alpha. It doesn't matter which specific side we're looking for. It has to be that we know the angle of that side. And if I'm trying to find the angle using law of cosines, I need to know all 3 side lengths, all of them. So we're going to use both of these today. So write these down because we're going to solve some triangles today. Any more time to write it?
Yeah.
Okay. Okay. So the reason we have these and we can't just use law of sines for absolutely everything is because if I give us a triangle that looks like this, law of sines isn't going to do much for us because I don't have a complete pair on any of these sets. For angle A, I don't have side A. For side C, I don't have angle C. And for side B, I don't have angle B. So I don't have a complete pair, so we cannot use law of sines. So that's why we have law of cosines, is it helps us when we don't have that full set to be able to do law of sines. So we are trying to solve the triangle. The little triangle symbol? No, the triangle symbol didn't show up for you guys either. I love that so much. We're going to solve the triangle. There we go. Instructions finished. So solving the triangle means we want to figure out what side A is. We need to figure out angle beta, and we need to figure out angle gamma. That's the one that's in the C. Looks kind of like that. So we can't use law of sines because I don't know any complete pair. I don't know anything where I could make a full fraction. So we have to use our law of cosines. So since I don't know all three sides, I cannot use the angle one. I know two sides and an angle, so I'm going to use the one that we're looking for a side. We can find side A here using our a squared equals our, I'm just copying it down here so it's a little bit bigger, plus our c squared minus 2bc with cosine of alpha. I wrote it all down with the letters, just with the color coding. We're going to put our values in there. So side B is which one?
26.
26. This is our B. It's opposite the angle beta. That's our side B, which means side C is the 19. So that's C. So in our formula up here, we're going to put in our 26 squared plus our C squared, that's our 19, minus 2 times our B, which is 26, times our C, which is 19, and then cosine of angle alpha, which is 62 degrees. That's this guy. And we can type all this into the calculator.
I'm guessing we're gonna have to memorize that.
We're gonna need to memorize the formula.
You know, having some homework.
Yeah, we're gonna need to know the formula. Just saying. Yes.
I've been through the course.
486.84. Oh wait, square it? That's square, right?
All right. So sometimes it helps to do things in smaller chunks, just because, like, things get a little bit crazy sometimes.
Is this to find the angle or the side?
We are trying to find the side.
Okay.
So we've got this guy. We're trying to figure out what A is.
Hold on, I got it now.
So you can do it in little chunks. You could do our 19 squared. We could do our 26 squared. We could multiply this whole chunk here in the calculator. You could type everything in carefully. We should get
63,
that our...
3, 2.
No. I don't think so. Make sure you're good.
I feel like 573.
Yeah, it should be 573-ish.
I thought it was like.
You messed with your order of operations. Because you did this plus this times 2.
Yeah.
These is one chunk. This plus this minus that.
No, I
Dude, that is a chart.
I multiply those minus. Oh, -2. That's attractive.
Why did you times it by 2 there then? Because that was your
My bad.
26 squared plus your 19 squared. Okay, type things in carefully. You can either do it as one big row, or you can do it individually, but just be really careful, because we should wind up with our A squared about equaling 573.16209, blah, 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 blah. I'm gonna go 16. So what is A?
23.9.
Yes. 23.94. We can. So, because we still need to figure out what beta is, we still need to figure out what gamma is. You can do law of sines. We can do law of cosines. What's up?
So let's say like you just round it up by 24, just to like make sure I
We will tell you where to round. So you don't get to make the willy-nilly choice. And I've made sure, for sure, on the quiz it says where to round. Most of the time it's going to be hundredths, just because more than that is a little petty. So you can do our law of cosines to figure out one of these angles, or we could do law of sines. Since now I have a full pair, and we're trying to figure out both of these pieces. So I know most of you guys were very excited to hear we could do law of sines, so we can do that. Since we're looking for our angles, do you want to find beta or you want to find gamma first?
Beta.
Beta. So how are we going to set it up to find beta?
26 times sine of 62 divided by 23.94.
Okay, we're going to set it up a step before that. Because you a step ahead. Like, we're going to set it up properly and then solve. So, since we're looking for beta, the angle, we're going to set it up with our angles on the top. So, we're going to have our sine of 62 degrees over our 23.94. That's our A. And to find beta, that's our sine of beta over 26. So what do we do to figure out what beta is? Multiply by 26. So that gives us that our sine of beta is our 26 sine of 62 degrees over 23.94. Is that the answer we want though? We got to do the inverse. We're going to do our arc sine of that hot mess. My beta is the inverse arc sine of that hot mess of a fraction. 26 sine of 62 over 23.94. So what do we get typing that into the calculator for our beta? I'm going to double check it just because I did it a different way. I'm double checking it. Of course I am. Because I did it law of cosines, which is going to give us a slight variation. Because it also does not match 76. 73.5.
Wait, why are we doing that again?
Because we found, with law of sines, we get that sine of beta is this guy. But I don't want sine of beta. I want to know beta.
Oh, yeah.
Okay, so we have to do the inverse to get rid of the sine. So now I know this angle is our 73.5 degrees. How do we figure out gamma?
We can add the angles to my beta
Mm-hmm.
or we can use like
You could law of sines it. You could law of cosines it. Or we can go, wait, all angles on a triangle add up to 180. And that's way easier. So what do we get for gamma?
44.1.
44.5. Because all of the angles in a triangle add up to be 180. Hey. I'm gonna take that. There we go. Cool. Then I just make sure it gets in the system right. Boop. Okay. So now I have all three sides. I have all three angles, so we solve this triangle. Questions on this one? So let's do next one. So we're gonna solve this triangle using our law of cosines.
Because you don't go to so it's like should never be stressful.
We are gonna use our law of cosines, because that's what this one's about.
Should use like a squared or cosine.
What?
Cosine of alpha, right?
Yes. So on this one, since we have side, 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 I can't use the exact same form we had on the last one because I don't know an angle. Since I only know sides, we're going to use this bottom one where it's solved for cosine. It's really, really important that you have your pieces be in the same relationship. So if we're looking for angle alpha, that means we need to pay attention that this is side A. This side is my side C, is the 13, and my B is the 8. Because there are differences in the signs, like the pluses and minuses, it makes a difference. It is important. So to find cosine of alpha, again, I'm going to write the whole thing out for us just with the color so we have it. Our B squared plus C squared minus A squared over 2 B C. Yeah, tell me.
A squared plus 13 squared, that's less than 20.
Mhm.
So it's going to be
That's okay.
domain error.
We won't get a domain error, but we gotta be really careful with the whole thing. Okay. So, hang on a second. We're on cosine of alpha. Let's substitute our pieces in first. So we're gonna have our 8 squared plus our 13 squared minus our 20 squared over our 2 times
I got 143 point.
I'm double checking. Let me see what you get, because I did it all as one fraction, so I got it to simplify for me. Those of you that are getting more than a 3-digit number, let me somebody send me your calculator. Let me see it. Oh, you're just trying to go for the whole thing.
Yeah.
I'm doing in between steps.
Okay,
I'm just good. I'm just simplify our numerator, simplify our denominator. Yes. Oh, yeah, it's like you're a step ahead of me. Yes. I was gonna say we're headed there.
minus 20 squared.
That's not 20 squared.
There you go.
And then you
Yeah, that's your numerator. So if we do this piece by piece, if you take your numerator and your denominator separately, we should get minus 167 over 208.
That's wrong.
2 times 8 times 13 is 208.
But we can't have a negative. We can't have a negative.
Why? Why?
Okay, I just wanna try it.
When I take the inverse of cosine, are there never negative values?
No.
I guess not.
I mean, yeah.
In quadrant 2, are your cosines positive or are they negative?
Negative.
So can I have negatives?
Yeah.
So don't freak out on that. Yes, you can. Yes, the answer is yes. Yes, you can have negatives. So we're going to do our cosine, inverse cosine of this fraction. I highly recommend simplifying to here first. Don't type this whole kit and caboodle in. It's too easy to make typos. So our alpha is going to be our arc cosine or inverse cosine of our negative 167 over 208. That is way easier to type in than trying to type in this whole kit and caboodle in one go.
I got 140.
Mm-hmm.
I got negative 53.
Why are you doing sine?
Because, like,
Oh, we're on cosine. We're on cosine.
oh.
Oh my goodness.
Okay, that's why. Yeah, so since it's cosine, we got to use inverse cosine. So just be real careful with it. Because our alpha should be
They're the same thing.
about 143.4. Huh? 143.4 degrees.
Oh, wait, I got the right answer. No, This looks a little big.
Yeah, it's 143.4. These triangles are almost never to scale because I'm just freehanding a triangle. So now we need to figure out our two other angles. You can do law of sines. You can also still do law of cosines. We just have to be careful if we're starting from a different angle that we make sure to adjust our pieces. But you can use law of sines. Since yes, dear.
So can we change, you know how it says cosine of A? Can we change that to be a different?
Yes, if you want to do pieces, just make sure we then have our angle and its side are in this relationship. So if you want to do this as cosine of beta, we need to make sure we subtract the b squared and that in the denominator it has the other two sides. So this would be 2ac, a squared, and c squared. So if you want to do a different angle, that is absolutely valid. We just have a cosine of our angle, and that's the piece that's subtracting. And then we have these two pieces here and here. So it's we're adding together the two sides adjacent, subtracting the opposite side, over 2 times our adjacent sides. So you can use law of sines, or you can switch our law of cosines to be a different one. We should get essentially the same angle. Might be decimally different, but just barely.
I have a question.
What's up?
So what if you got an angle like less than 0?
You should not get an angle less than 0.
So we're doing cosine, right?
Yes.
We wouldn't sign it, right?
I have no idea what you said. Say it again.
We wouldn't, like, you saw it, right?
I still don't know what you said because you know
What if you
you're if you use law of sines, you can use sine. If you use law of cosines, use cosine.
You saw it was wrong, okay.
So you can use law of sines because we have a pair now. So we could get gamma, we could get beta.
I think I'm just fried this. So, we pull up. I kind of, why?
You have smushed together cosines and sines now. You did law of sines, but using cosine. If you're going to use cosines, you got to use law of cosines. If you're going to use law of sines like that, you got to use sine.
I did 8 just like that, right? I didn't do a sign, that's what I got right here.
Every day of the
So that gave you the decimal. That is sine of beta. You didn't finish it. That is sine of beta, not beta. Inverse sine that number.
That number still there?
That is sine of beta. Write more steps. Stop doing so many things in one step. You're doing too many steps in one step, and you're getting yourself confused. So if you're going to do law of sines to find beta, sine of beta over side B, which is 8. And we can use our alphas that we know the whole thing of. Sine of alpha, which we know is 143.4 degrees. And side A is 20. So to figure out what sine of beta is, we get our 8 times that mass, sine of 143 over 20. But to get to beta, we need to take our inverse sine, that arc sine of that growth fraction. No, the quiz is just over 8.1 for tomorrow, which is law of sines only. Law of cosines is 8.2. So what do we get for beta?
Let's guess.
We don't need to guess. We can type that in the calculator.
Okay.
What's up?
13.8?
Yeah, 13.8.
No, that's 8.2. Wait, that's 8.2.
This is 8.2, correct. Law of sines is on the quiz tomorrow. Yes, law of cosines is section 8.2.
You got 8.2.
This is no, this is section 8.2. We got 13.8 as our angle.
You scared me.
No, we were in two separate conversations. You were just locked in. Yes. No, this is section 8.2. Angle beta is 13.8 degrees. Which means what's angle gamma?
23.6.
22.8?
I am gonna double check you now because we've had too many answers. And I didn't have it written down. We get 22.8. Huh? No. Because if I put 23 and then I added it all up, we would not add up to 180 degrees.
Oh.
So we can't round differently. It's better than that right at the end.
Bro.
No, just don't round to 23 degrees.
All really answers.
No, we're good. We're good. Okay. Questions on this one? I have all three sides. I have all three angles. The hardest part of this is the formula.
I'll never complain. I'm fine. I'm fine.
I mean, you are absolutely allowed to complain. That doesn't exempt us from doing it. But you're allowed to complain. Absolutely valid. Your feelings are valid. Okay. Questions on this one? Boop. Here's your next one.
I don't like drawing it myself.
Aww. So given triangle ABC, I don't know why any of my triangles are not showing up in the instructions. We get side A is 5 inches, side B is 8 inches, and side C is 7 inches. And we are asked to solve. So we got to find everything. So draw ourselves a triangle. What's up? Yes. We're given all the sides. We've got to find everything. We're out to solve the triangle. So we need some sort of triangle to look at just because it helps us remember our relationships. It doesn't really matter what kind of triangle you draw. We just need to make sure that we can tell what our relationships are. So it doesn't matter what pieces we name what, we just got to be careful with what sides we label. So I'll go A, B, and C. I'm gonna go like this. Genuinely, it does not matter which point you make which, as long as we have side A being 5, side B is 8, and side C is 7. So which angle, real quick, do we expect to be the largest angle?
B. Ankle B.
Angle B. The largest side is going to go opposite the largest angle. So our smallest angle is going to be A. So we can start this for any angle.
What do we switch around to the 10th to the 11th?
Let's go with rounding to the 100th. Just because that's going to be the most common way we have it on things like assessments. So since we are given all 3 sides, we're going to use this guy. That'll help us find an angle. And we can pick any angle we want to go first. Since it's set up for alpha, I'm going to go ahead and use it to find alpha first. If you want to find beta or if you want to find gamma first, more power to you. Just be really, really careful when you're adjusting things around. So setting this up, we're going to have our cosine of alpha equals, bless you, our b, which is 8 squared, plus our c, which is the 7 squared, minus a, which was 5 squared, over 2 times the b times the c. On these, I do highly recommend that we simplify before we try and do an inverse. Because we can find out that our cosine of alpha is going to equal 8 squared plus 7 squared minus 5 squared. There we go. We should not get 11.
I got 11 over 14.
Oh, it might have simplified for you. I was gonna say, if you type it all in as one fraction, because what I get, pure off those numbers, I get 88 in my numerator. And our denominator of 112. If you type that in as one fraction in the calculators, the yellow calculators will auto-simplify it to be 11 over 14. Either way is totally fine. It's just whether or not you put it in as numerator separate from the denominator, or if you put it in one giant fraction, it just auto-simplified it. Either way is totally fine. Both are right. So to find alpha, we are going to use our inverse cosine. So we're going to use our arc cosine of our 88 over 112 or of our 11 over 14. Either one. What do we get for our measurement of alpha?
38.2.
It should not be 99.
38.2.
Should be 38.2. So now we know that alpha is 38.2. And we can find beta, we can find gamma. We can do it using law of cosines, we can do it using law of sines. Either way. So we've got our gamma here, we've got our beta here. Which one you want to do next?
Gamma.
Gamma. Are you gonna use law of cosines or law of sines?
Fine.
Law of sines. Sounds like a plan. So we can do our sine of gamma over 7 and our sine of 38.2 degrees over 5. So what are we going to get for gamma?
59.
60.
I think 59.99.
Mm-hmm. Yeah, we're going to get like 59.999. Like it's going to get real tight on there.
Would you accept 60.1?
Let me get our like full decimal so I can actually see what it is because I did it a different way in my notes, which is totally valid. But if you do it with law of cosines, it comes out absolute perfect. Bow. I was gonna say, yeah, we're at 59.97, or we could have 60. If you do it with law of cosines, it winds up at exactly 60. But I would absolutely take 59.97 or rounding it up to 60 if we're going for one decimal place. I'm gonna go with the 60. Since we were at one decimal place, 60.0.
Do you have like a decimal, like a one off or something?
I was gonna say, it should be relatively close, but honestly, it depends on what technique we use to get there.
Because I did beta first and I got like 60.1.
Oh, you're just doing it in different steps. Okay, cool. Then you were just playing with things. I'm like, what are you doing there? I don't know. That's okay. I was like, you did things. I don't know what we were doing, but we did things. Yeah, because that's one we wanted. What was that? What were those two?
Oh, I subtracted so that I could get the angle, like the other missing angle, and then I just made it pop.
Okay, cool. So you're okay. I was gonna be like, what are we doing? I don't know. Yeah, that's fine.
Yeah.
I was just very lost. I'm like, cool. You were just ahead of me. Awesome. I just hadn't gotten through thinking that part yet. Yeah, so we've got our 60 degrees, which means what do we get for beta?
21.8.
81.8.
Ooh,
Yeah.
vast variety of choices there.
Like right here.
Something in there.
Yeah, 81.8. Just checking. I had a lot of variety.
Sorry.
Double checking. Yeah, it should be about 81.8. Somewhere around there. Honestly, it depends on when we round and where we round. So the earlier we are in a problem and the more we round, so like if you put this in as a decimal, your numbers may be slightly off. So the more decimal places we leave earlier on, the more accurate our answer is. So don't round these things to like tenths or hundredths, or it's going to make things get kind of further off the farther we go. So the more accurate we are when we type things in, the easier it's going to be. Okay? So we've got 3 minutes left. I'm not going to start another one. Okay?
I didn't.